Hi, third graders. We are getting ready for our first mid-module assessment, which is just a little quiz that we take in the middle of our first unit on multiplication and division. What I wanted to do first is I want you to grab this paper. If you don't already have it ready, it says Module 1, Quiz 1. This is not really a quiz, so don't let that word quiz scare you. We can actually cross it right out, and we can just put review. This is just a review sheet that we're actually going to use to get ready for our mid-module assessment. Okay, so this is not, we don't just hand you a whole packet of tests to do when you picked up your new materials for the week or for the month. We're just getting ready. This is a review, and then we'll have a mid-module assessment after this. So I want you to pay very careful attention as we're going over this. And I want you to make sure that you're doing everything right along with me. And if you have any questions, you can always pause that video and go back and rewatch it, okay? So pay careful attention. If there are things that you're not sure of or things that don't make sense, you can pause it and rewind it and go back, okay? All right, so we're going to jump right into this. So if you need to pause and get your materials, you can, but here we go. So number 1 says, which expression best represents the picture below? So one thing that we're going to do now, and then I definitely want you to do when you take your mid-module assessment, is to label the pictures, label the arrays, because it will absolutely help you. So when we look at this picture, we have 2 groups of 4. So I'm going to put 4 and 4, okay? Now, as a repeated addition sentence, I know that I would just add those 2 numbers together. So if I look, I have 2 4s, 4 plus 4, and I look at my choices. I want to look through every single choice and find one that works, and I can cross off the ones that don't work. So the first one is 2 plus 4. Does this show 2 plus 4? No. So I'm going to cross it right off. B says 4 plus 4. Does it show 4 plus 4? It sure does. So we think it's that, but we shouldn't just choose it automatically. We should look at the other choices, because sometimes some of the questions or the choices can be tricky and we think that they're correct, but they're not. So we always want to make sure that we're looking through all 4 of our choices if we're dealing with a multiple choice question. The next one says 2 plus 2 plus 2 plus 2. Does this picture represent 2 plus 2 plus 2 plus 2? They're not groups of 2s. And then so we can cross that one off. And the last one says 4 plus 4 plus 4 plus 4. Does the picture show 4 plus 4 plus 4 plus 4? No, that has 4 4s, and there's really only 2 4s there. So we can cross that off. And our original thought of B being correct is correct, but it is absolutely a good habit to make sure that we check all of our answers. Good job. Look at number 2. Which expression best represents the picture below? So again, now we have groups of bananas. So let's label our group. So how many bananas are in each group? 3, right? So 3, 3, 3, 3, and 3. Okay. So I have 1, 2, 3, 4, 5 groups of 3. So there's 5 groups of 3. So if I look at this, the first choice, A, is 3 times 3. Is that correct? No, if it was 3 times 3, there'd be 3 groups of 3. So we can cross that one off. B, it has a 5 and it has a 3, but it says 5 plus 3. Are we adding? No. And this is one of those choices where it could be tricky, okay? Because you might say, yeah, there's 5 groups and there's 3 in each one. That's it. But it's not. So this is where it would be good for you to look on. So maybe you think, yep, that's my answer. But then if you look at C, C says 5 times 3. It has that 5 and a 3. So that should make you stop and say, they both have a 5 and a 3. Am I adding? Am I multiplying? Which one? In this case, we're multiplying, right? Because we have equal groups and we're trying to find the total. So we're not adding, so I can cross off B. I think it's C. What do you think? But let's look at the last one. Okay, so C, I don't know. This is looking good. We have 3s. 3 plus 3 plus 3 plus 3 plus 3 plus 3. How many groups of 3s are there in that one? There's 6. And how many bunches of bananas? 1, 2, 3, 4, 5. So that is not correct. So C is the correct answer there. Okay. Moving on, rewrite the following addition problem into a multiplication problem. So in this one, I have 1, 2, 3, 4 groups, 4 threes, right? So 1, 2, 3, 4, since there's 4 threes, if it helps to do 1, 2, 3, 4, and I can stick a 3 in each one, that can help me to see that there are 4 threes, right? The first number in my multiplication sentence is the number of groups, and there's 4 groups. How many are in each one? 3. So 4 times 3, okay? We don't even need to find the answer if we look at our choices, but let's look at our choices. The first one is 3 times 4. Well, we said 4 times 3. Does 3 times 4 work, though, if we use the commutative property? Is that technically correct? Yep, but let's look at our other choices. B is 3 times 3. That's not correct, right? Because we had 4 threes. C is 4 times 1. Well, that's not correct at all, right? And then D is 4 times 4. That's also not correct at all. So maybe you looked at A and maybe you said, okay, well, it's definitely not that and it's definitely not that. And maybe you had crossed off A right off the bat because it said 3 times 4 and you had thought the answer was 4 times 3. But then if you look at the rest and we crossed off the rest, then you might go back to A and say, I had 4 times 3, but this says 3 times 4. And then you might think to yourself, well, technically that is correct because there are, I can use that commutative property to flip-flop the 4 and the 3. Okay, so that is our correct answer there. Okay, moving on. Make sure you're staying right with me. Number 4 says, which multiplication equation represents the following array? So remember, with an array, we have rows. So I'm going to count my rows. 1, 2, 3, 4, 5. Should you do the same thing on your paper as I'm doing with mine? Definitely, right? So there's 5 rows. So I'm going to put that 5 right there to represent those 5 rows. And remember, rows go this way, right? And then how many are in each row? 1, 2, 3, 4 in each row. Okay, I can put that times sign in the corner, and then I can see if I can find a multiplication equation that represents that array. Well, if I look, 5 times 4, oh, look at the first one. 5 times 4 equals 20. Let me see if this does equal 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is correct. I think it's that, but I need to check my other choices, right? B says 5 times 3 equals 20. Well, no, there's 5 rows and there's 4 in each row. This is why we need to count carefully, because sometimes if we're counting really fast, we might think that there's 3 in that row. And then we look and there's a choice for that. So you want to make sure that you're paying careful attention and you're counting carefully, because it's easy to make a silly mistake like that, and we don't want to lose points on a test for not being careful. So it can't be 5 times 3 because there's 5 rows of 4. The next one says 5 times 2 equals 10. Well, that's a silly answer, right? So sometimes the rest of the answers, we can cross them right off. The last one is 5 times 1 is 20. Well, we know that is a crazy answer, right? Because 5 rows of 1, 5 times 1, we know from doing our multiplication with our week of times 1 and 0, anything times 1 is always that other answer. So it can't be 5 times 1 equals 20. So our original answer of 5 times 4 is correct. All righty. Number 5, choose the expression that represents the array. Same thing. So let's count our rows. 1, 2, 3, 4. 4 rows. And how many in each row? 1, 2, 3, 4, 5, 6, 7, 8. Put our times sign in the corner. Is there one that matches this? There sure is. It is B. Okay, so again, it can't be 4 times 7. I can cross that off because there's 4 rows, but there's 8 in each row. And I'm going to count again just to be sure, since there's so many other choices. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it can't be 4 times 7. It can't be 4 times 9. And it can't be 4 times 10. So it is 4 times 8 because there's 4 times 8. Okay. All right, if at any time you want to break off and pause the video and break off and try to do this on your own and then come back and check your work with me afterwards, you are more than welcome to. I will just say make sure to come back and watch the video afterwards to check your work with mine in case you made a mistake or you can see a different way to solve it. And I'm trying to show a lot of different tips when we take a math test in particular because it's easy to make silly mistakes. Okay, so if you want to break off, work independently, that's fine, but make sure you come back and watch the rest of the video or stay with me. Okay. All right, number 6, Natalie is given the equation blank times 5 equals 25 to solve. Which of the following is the missing factor for Natalie's number sentence? So we have blank times 5 equals 25. Well, I know my total is 25. I'm missing the first number, which might be my number of groups, but I know that there's 5 in each group. I'm going to make an array, and I'm going to put 5 in each group. 1, 2, 3, 4, 5. And I'm going to keep going until I get to 25. So I've got 5, 6, 7, 8, 9, 10. Are you with me? If you need to pause it to get caught up, you can. So I have 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and stop because I hit that 25 mark. So now I need to see how many rows I have. 1, 2, 3, 4, 5. 5 rows. And there's 1, 2, 3, 4, 5 in each row. Put my time sign there. And if I do that work, it makes it so easy to fill in that blank now because I've got 5 times 5 and I had a total of 25. So what's that missing blank there? 5, right? Which means the 5 goes there, which means what is my answer here? It's 5, right? Another way to solve it, if we feel more comfortable, is since it's times 5, I can count by 5s until I get to 25, right? Will you do that with me? 5, 10, 15, 20, 25. And when I do that, I counted by 5s 5 times. So that also tells me that my answer is 5. So it just depends on what you're more comfortable with. But drawing a picture is always a really great way to make sure that you get it. Okay. Even if you think you know, you could always draw a picture to help you. Okay. Turn it over. Number 7, Gilligan made arrays with his snack to show the commutative property of multiplication. We want to label each of these arrays. So if I look at the first one, I've got 1, 2, 3, 4, 5, 6 rows, and 1, 2 in each row, 6 times 2. And the second one, I've got 1, 2 rows. Should you do this too? 2 rows and 1, 2, 3, 4, 5, 6 in each row. Okay, so for the first one, I have 6 times 2 equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Speed counting there. And the second one, I have, well, look, they're the same numbers that I'm multiplying, right? So here I had 6 and 2. Here I have 2 and 6. What did I do to my array? This one was standing up, and I took that same array and just turned it onto its side. So what property did I use there? I use the commutative property. So if 6 times 2 equals 12, then 2 times 6 also equals 12. I don't even need to do that counting there, right? So now I want to find a multiplication sentence that matches my array. A says 2 times 7 equals 14, and 7 times 2 equals 14. Is that correct? No. But can I tell you, I have so many kids every year that pick A as the correct answer. And do you know why they do that? Because they're not counting carefully. This is not hard, right? If we label it and just count carefully, that's not hard. So if you're choosing A, we're not counting carefully. So you want to make sure that you just put in those extra 30 seconds to count carefully. Not even 30 seconds, right? Okay. B says 3 times 4 equals 12 and 4 times 3 equals 12. We don't have 3 rows of 4 and 4 rows of 3. 4 times 6 equals 24 and 6 times 4 equals 24. Nope. Here we go. D, 6 times 2 equals 12, and 2 times 6 equals 12. There we go. But again, we want to make sure that we check all our answers. Number 8. How many groups of 6 can you make with the 18 shapes below? So we want to make groups of 6. And there's 18 total shapes, so I'm going to circle groups of 6. So there's 6. There's 6. And there's 6. 1, 2, 3, 4, 5, 6. So how many groups did I make? 1, 2, 3 groups of 6. If I wanted to write a number sentence for that, 18 is my total. I'm dividing by 6, and I had 1, 2, 3 groups. Again, boys and girls, if it's ever going too fast, pause the video and just get yourself caught up. Okay, I'm just trying to keep moving on through here. But if there's anything where you need a little bit more time, just pause your video and catch up, okay? And then come back to me and I'll be here. All right, number 9 says determine how you would express the groups shown as a division problem. So we want a division number sentence here. So if I look, I have 3 groups of 6. So I have 6, 6, and 6. I know that when I divide, what number always comes first? When I divide, it's the total first. So I need to find the total of all of these stars. So I have 6 plus 6, which I say, I know that 6 plus 6 is 12. And then maybe if I add 6 more, I already know that in my head. But if I'm not there, I can say 6, 12, 13, 14, 15, 16, 17, 18. Or maybe I want to touch every single star and count, and that's okay, right? But I just found out that total there's 18 stars. So 18 is going to be my first number because it's my total. And I'm dividing by, well, let's see here. It says determine how you express the groups as shown by a division problem, how you'd express the group. So really, we can do 18 divided by 3 because there's 3 groups equals 6, okay? And that second one too, it really, A and B, I would honestly take because we can rewrite that as 18 divided by 6 equals 3. So that's trying to get a little bit tricky there, and really either one would be fine there, okay? All right, number 10. If 27 divided by 3 equals 9, then 27 divided by 9 equals blank. What property is this? That's that commutative property, right? So I have 27 as my total divided by 3 equals 9. Then here's 27 as my total. I'm dividing by 9. What would be my answer? Do you think it should be 3? I agree, because here I have 27, 3, and 9. 27, 3, and 9. I'm working in that same fact family, right? Because 3 times 9 equals 27. 9 times 3 equals 27. 27 divided by 3 equals 9. And 27 divided by 9 equals 3. So those are all in that same fact family there. So the answer there would be 3. And just looking through, those aren't correct there because those aren't even in part of that fact family, okay? And I didn't go back here. So really I said I would accept A or B on that one. For C or D, looking back at number 9, because I didn't eliminate the other choices, C can't be correct for number 9 because that's saying that 6 is the total number of stars. Remember when we divide, the first number is the total. There's way more than 6 stars total, so it can't be that. And same thing here. We're starting with 6. That can't be correct there either because 6 is the amount in one group. 6 is not the amount of stars total. Okay? Turn the page. Oh, we got Juanita, and she's drawing some dogs for the next one. Okay? So here we go. Juanita drew 5 dogs. She drew 4 legs on each dog. How many legs does she draw on all 5 dogs? So she drew 5 dogs. So I'm just going to bracket that. Juanita drew 5 dogs. She drew 4 legs on each dog. I'm going to bracket parentheses around that. And then my question says, how many legs does she draw on all 5 dogs? Okay, so if you want to actually draw dogs, you can. I'm not going to show my artwork right now. I'm actually not bad at drawing, but we're just for time's sake. So 5 dogs, that means 5 groups. 1, 2, 3, 4, 5. And she drew 4 legs on each dog. So I'm going to put 4 in each group. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And you don't have to do an equal groups picture. You could do an array. We started tape diagrams. You could do a number bond. So if there's a strategy that you like more, you're certainly welcome to use that. Okay. So I'm also going to do a count by underneath this. So I have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. My question says, how many legs does she draw on all 5 dogs? Well, there are 4 groups. No, sorry, there's 5 groups. 5 groups, 1, 2, 3, 4, 5. And there's 4 legs on each one, and we found that answer was 20, which is choice C. Can't be 9. 9 would be if we did 5 times 4, but we're not adding. That's why it's important to do a picture. Definitely not 14 and not 25. Okay. Look at number 12. And that does bring up a good point, boys and girls. I want to go back to this. When you do your mid-module assessment, I want you to draw pictures for ones that don't already have a picture. If it doesn't have a picture, draw a picture, because so easily a lot of kids look at 2 numbers and you just automatically want to add them together, because that's just where our minds go a lot of times in math, is just to add. Draw a picture. If there's not a picture there for you, draw a picture, and then it's so much easier to see. Okay. All right, so number 12, which number sentence does not represent the array below? So which one does not represent this picture? So I'm going to look, and I have 1, 2, 3, 4, 5, 6 rows. And there is 1, 2, 3, 4 in each row. Okay, so there's that. If I were to multiply, so let me just write my number sentences here. I could do 6 times 4, and if I add up all those together, that equals 24. Okay. I could use the commutative property and flip-flop, and this time say 4 times 6 equals 24. Okay. And I look at my choices, and I actually see both of those there. But it says which does not represent the array below. I can actually cross both of those off. And a lot of times kids see that, oh, the first one is 4 times 6. Yep, that works. So circle it and we're done. But that's not the case, right? So that's why it's important to look. If you looked at B, you could say, oh, yeah, that works too, right? So it says which one does not represent the array below. The next one says 12 plus 12 equals 24. Do we see 2 groups of 12 here? If it was 12 plus 12, we would have 2 groups of 12. So it doesn't show that, but let me look at D. D says 6 plus 6 plus 6 plus 6 equals 24. And you might say, well, there's 4. 4 plus 4 plus 4 plus 4 plus 4 plus 4 equals 24, not 6. But what if I did this? If I turn my paper, does it now become 6 plus 6 plus 6 plus 6? It sure does, right? So that's actually correct. 6 plus 6 plus 6 plus 6 is correct. So that leaves us with C is incorrect. So again, it's just a matter of taking our time and looking through all of our choices to see which one does not, and catching right from the beginning that it wants to know which does not belong. Okay. Which expression is represented by the model below? I've got 1, 2, 3, 4 rows in this array. And there's 1, 2, 3, 4, 5, 6, 7, 8 in each row. So I can put that time sign there. Okay. So looking at that, it could be 4 times 8. I could use a commutative property and say what? 8 times 4, right? Let me look at my choices though. A says 4 divided by 32. Well, I didn't even find my total yet, but could A work? A cannot be correct because when we divide, we start with a total. And 4 is not the total, it's the number of rows. So I automatically know that one's wrong. Okay. B says 8 divided by 4. Well, I should know that that one's not correct too, because 8 is not the total. 8 is the number in each group. So that's not my answer. C says 8 times 4. Well, I already wrote 2 multiplication sentences, and that is one of them. So yeah, maybe. D says 32 times 4. Well, I'm going to tell you, if you count up all of these, it does equal 32. Let's pretend we already did that. But D says 32 times 4. What's wrong with that one? 32 is the total, so we wouldn't be multiplying by 4. We would be dividing. So that one is incorrect too. So our correct answer there is C. Okay. All right. Moving on. Number 14 says Frederick has 3 toy bins in his room. There are 9 toys in each bin. How many toys does Frederick have in his toy bins in all? So 3 toy bins in his room. I'm going to put parentheses around that. There are 9 toys in each bin. I'm going to put parentheses around that. How many toys does Frederick have in his toy bin in all? So we're looking for the total. So that means we're going to multiply. If we already knew the total, we would divide. But since we don't know the total, we're looking for it, we're going to multiply. I want to draw a picture. 3 toy bins in his room. I can do an equal groups picture. I can do an array. I'm going to do a tape diagram for this one. 3 toy bins. I'm going to do my rectangle. And there's 3 toy bins, so I'm going to put 2 lines to make those 3 groups. You could do an equal, whatever works, boys and girls. If you want to do an equal groups picture, an array too, that works. I'm just going to do this, okay, for the change. 3 toy bins, so there we go. 9 toys in each bin. Okay, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have 3 rows of 3. So I'm going to count on. I'm going to do a count by random. So there's 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And I'm going to keep going. So I need 9 more. So 3 more rows of 3. So I'm at 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. There we go. There's 9 toys in each bin. How many toys does Frederick have in his bins in all? He has 27. Okay. Good. And again, if you need more time, you can pause the video. You can rewind to watch something again. Whatever works best for you. Last page. I added a couple that I wanted to look at there, but let's just focus on number 15 for right now. So the bake sale has 3 rows of 4 cookies. So here we go, 3 rows of 4 cookies. The bake sale adds 2 more rows of 4 cookies. I don't really have room to do that, do I? I'm just going to redraw this right here. If you want to redraw it with me, you can, or if you think you can squeeze it in underneath. Okay, 3 rows of 4 cookies. Boom. The bake sale adds 2 more rows of 4 cookies. So I'm going to add in 2 more rows of 4 cookies. Okay. How many cookies are in the bake sale now? So the first top of that, there's 3 times 4. And if I find the total for that, 3 times 4 equals, well, I can touch each cookie and count, or I can count by 4s or 3s. I'm going to do 4 plus 4 is 8, plus 4 more is 12. So that top equals 12. The bottom is 2 rows, and there's 1, 2, 3, 4 in each row. So that gives me 4 plus 4 is 8. So 2 times 4 equals 8. The top is 12. The bottom is 8. What do I do with these 2 parts? I'm going to add them together. So 12 plus 8 equals, you know what that equals? It equals 20. And so how many cookies are at the bake sale now? I do have 20 for my answer there. Okay. And it's not 12 because 12 is the top. It's not 16 because we had to add 8 more. And 24 is too much. Okay. How are we with that? And I would definitely say to redraw that one because we would have to, if you did add, squeeze in little tiny ones underneath there. Sometimes with this in the past, kids have drawn this and they have drawn the rows off to the side, but they're not adding more rows, they're adding more columns that way. So when it says that you're adding more rows, make sure that you add them underneath. Okay, I added just a couple more in that I wanted to do quickly. Obviously, you don't have this on your sheet, but I want you just to show the work with me because we have all that room at the bottom. On your mid-module assessment, there's a couple more that are like this, so I wanted to do this right now with you. Okay, so number 16 says there are 15 cookies on the baking sheet. There are 5 cookies in each row. How many rows of cookies are there? Okay, so there are 15 cookies on a baking sheet. That is the total. So I would circle that. Okay. There are 5 cookies in each row. I'm going to put parentheses around that. 5 cookies in each row. My question says, how many rows of cookies are there? I want to draw a picture. right? So remember I told you, boys and girls, if there's not a picture, to draw a picture. So 15 cookies is the total. There's 5 cookies in each row. 1, 2, 3, 4, 5. So I want you to draw this with me, okay? So you don't have the rest of this, but you can draw the picture with me. So 5 in each row. I'm going to keep making rows of 5 until I get to 15, right? So there's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and stop because I hit that 15 mark, right? So that gives me 3 rows with 5 in each row. And so it says, how many rows of cookies are there? Well, there's 3 rows of cookies, right? But I want to write a number sentence. So I start with my total because I'm dividing this time. Since I knew the total, I'm dividing. So it would be 15. And we're dividing by 5 because that's what we knew. So 15 divided by 5. And once we did the work there, we found our answer was 3. If you wanted to write a multiplication sentence, you could. Because then I know that I'm just taking those same numbers and I'm plugging them in here because I'm in that same fact family, right? So how many rows of cookies are there? There are 3 rows of cookies. Super. The last one says there are 20 flower seeds. Stella wants to plant the seeds equally between 5 pots. How many seeds will be in each pot? 20 flower seeds. Well, that is the total. Okay. She wants to plant the seeds equally between 5 pots. So plant equally between 5 pots. My question says how many seeds will be in each pot? So again, I know the total and there's 5 pots, so that's how many groups there are, right? So I'm going to do an equal groups picture, I think. So 5 pots. So I'm going to do 5 circles. 1, 2, 3, 4, 5. And there's 20 flower seeds, so I'm going to put 1 in each group until I get to 20. Are you ready? Will you count with me? So if you need to pause it to get your paper set up, you can do that. You had all this room on your paper, so I wanted you to draw it with me. So you should have 5 groups, and here we go. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and stop. We hit that 20 mark. Okay. So looking at that, it says how many seeds will be in each pot? Well, there's 4 seeds in each pot. What kind of a number sentence am I going to write for this? I know the total, so I'm going to divide. So 20 divided by, I look in my word problem to see what I know. I knew the 20 and I knew the 5. So 20 divided by 5 equals 4. There's 4 in each one. So how many seeds will be in each pot? There will be 4 seeds in each pot. So this is really like RDWW, right, that we've been doing. We're doing a review now, so I'm not really worried about that right now. But just make sure that, again, when you are doing your mid-module assessment, if there is not a picture, I want you to draw a picture. So I'm going to look at it really quickly with you. Oh, I'm going to grab some extra papers there. This obviously doesn't need a picture, but you should label. Okay, this is your mid-module assessment that I'm looking at, boys and girls. Okay, label it. Number 2, label it. So right underneath how many are in each one. Number 3, label the side lengths of your array to help you figure out which one and make sure you're crossing out the ones that you know are not correct. Number 4, we have another array. Label your side lengths and put your time sign in the corner. Number 5, put PIC right off to the side there to remind yourself to draw a picture. Okay? Draw a picture there. Even if you have to underline it, put a star there to draw a picture because that will help you. Number 6 does not have a picture and it's a word problem. So again, put a star and put PIC, which stands for picture. Okay. This one says to divide the shells. You don't need to draw a separate picture here, but circle groups. This is your actual test. So I want you to write these little clues on the side of your test, just like I'm doing right here. Okay, so circle groups here, and that will help you to get your answer. If you need to pause it, you can pause it. On the next one, for number 8, you can put a star and put PIC for picture. You're writing a number sentence for number 9. Okay. Number 10, and actually, let's see. Yep, this one goes too. So you need a picture here. For number 10, these are your directions for number 10, that she plants 2 rows of 5 carrots in her garden. So you're going to want a picture here. Okay. And in this picture, you're going to use X's to show each carrot. Number 11, this is part of number 10, just so we don't get confused. It says she adds 3 more rows of carrots to her garden. So you're going to add to your picture. I'm giving you a lot of hints right now for this test, aren't I? Okay. And then find the total number of carrots, your multiplication sentence, and your division sentence to finish it off. So I just wanted to go over that real quickly with you, because if you were here, that's what I would be doing with you as well. Just since it's our first one with math. So any place where we put a star and we wrote pick, those are places that I want you to be sure to draw a picture. Circle groups for that one. If you need to pause or anything to go back and find those reminders, you can. But work really hard. If you want to take a brain break before you go into your mid-module assessment, do that. Make sure you're working independently on your own. This is what you can do on your own, and we'll work from there. Okay? I am proud of all your hard work, so keep it up, and I will talk to you soon.